Hi, I'm Jessica Bayless, and I'll be talking about teaching data-oriented design in introductory programming. And I wanted to just say that I've taught this in a couple of classes now. The introductory programming one is a course for transfer and bridge course students. It's kind of like a combination CS2, CS3 sort of course. I've actually taught it for 2 whole years now, and I'll be going into another year, hopefully soon. And this particular course, since it's kind of a combination CS2, CS3 intro course, it's got a lot of materials, especially since the students coming in, they already have some background. And sometimes they have a different background from each other because they've come from different places. And so generally we do a fair amount of review because there's always one person in the class that doesn't have something in the review category. For instance, we always have at least one student that has never done computational complexity. So we have to go over everything in review, and we normally, if we have a group of students that have not seen it, we'll spend a little bit more time on it. There's some flexibility in the course because of the way it is. So there's a group of things they generally know, there's a group of things that some of them probably know, and then there's a group of things that they pretty much never know. Data-oriented design is in the they never know this category. Strangely enough, also version control is there. I don't know, I guess other courses don't teach version control early. I tend to find it convenient myself. So there's a list of things there that they've almost never seen. And so because there are so many things I have to cover in this course, I do what I call a minimal introduction to data-oriented design because there's a lot of different things I have to go over just to make sure they get the basics, kind of the foundation of the pyramid so that they can learn other things later on. So there's not a lot of room for a lot of new materials. I do have the flexibility because so many of them have previous knowledge, and actually their knowledge tends to be pretty good about some subjects like sorting and searching. So I don't spend a lot of time on those particular subjects. And actually I survey them before I go in to see how comfortable they are with certain topics. They tend to be the least comfortable with things like complexity and with anything involving software design. They're unsure of anything involving software design. So how the course works, it's 4 hours a week, 2 hours and 2 hours, so 2 days a week. And it's an active learning lab, so I do a lot of exercises, that they can do on machines. So it's a combination lecture and then exercise, also with homework assignments. There are a couple of exams in the course, and there's a final project the last 4 weeks of the class where they do a game project. I don't do a lot of group work in this class because there are other courses that do that. And also some of the topics like version control, I introduce it in class, but then they demonstrate their knowledge of it outside of class because they use it on every single assignment. So the topics related to data-oriented design that I do in this class, I start off with, this is my minimal set of topics. If I want to talk about data-oriented designs, I always talk about the hardware cache because you pretty much, it's so important if you want things to run decently. I talk about data-driven design, and I'll say why in a little bit. And then I go over the basic tenets of data-oriented design because it's data-oriented topics. So I also have to do a few different topics in order to just introduce Unity and ECS. Like they have to know something about threading, parallel for, some Lambda function stuff, reference versus value types, which a lot of this they should know anyway when they're learning some intro stuff. And also structs in C# are very different because they're value types and not reference types. So you have to learn them because some of the students in my class will have come from C++ background and they won't understand that struct is very different. And then I go into an intro to Unity and their ECS and job system. I start out from the first week with some of these topics. So this is my first homework assignment. I actually give it out the first week. It's due at the end of week 2 because sometimes people join the class late. And the idea is we're going to use Git and do some version control. We're going to learn how to profile because we're going to be profiling through the whole class. And then we're going to actually add some methods to a C# project because some of them have never done C# before, some of them have never used Visual Studio before. And then we're going to write a report on what profiling all this different stuff that we added into the program actually does. So it teaches us, a variety of concepts around the tools and, how to profile. And then we get some interesting results that we talk about in the report. And I don't require that the results be right at this point. And then we compare the code that they had. The main two are Grayscale 1 and Grayscale 2. It's turning an image into grayscale. And what happens is in Grayscale 1, it goes in order of the memory, so it doesn't miss cache as much. And in Grayscale 2, it goes down the columns, so it's missing cache all the time. And you find out there's a pretty big performance difference between the two. And so then the students, the goal is for them to become curious. So this is Grayscale 2, this is the bad one. Grayscale 1 is just the for loop switch. I actually had to write this very specifically. I wrote a single dimensional array so that they could more easily tell what the memory order was, because it's an intro course. And so at that point, they're like, but this code is the same. You switch the for loops, but they're still doing the same thing. And some of them still try to make it so that this code is doing something different somehow, but it's the same. Logically, the code is the same, but it performs differently. And then the students are like, what the heck is going on? And they become really curious about that. And after the assignment is turned in, like the day after, I actually talk about it in class. And we go over, like what the heck is going on with this assignment? They get no credit off if, in their discussion, as long as they carefully considered it and gave me pictures of what their performance was. And, we talk about things like cache. And at that point, they're like, oh, okay, so the hardware actually does matter, because it does. And then I have to lay more groundwork for data-oriented design, but I have to do it in combination with other things because this course has a lot of different topics in it. And so what I do is a text adventure, and it uses a lot of object-oriented design concepts. So I have this concept of a room in the text adventure, and so they're creating different rooms, which are different objects. They usually make them different classes. They use polymorphism and have inheritance. So they're remembering all this stuff having to do with object-oriented design, just in terms of how to do it and how to do the code and stuff for it. They use singletons. They get to create a game loop, which is a very simple one because it's just text. They look at model view controller just so they can see, like what this thing is, because one of their weakest points is actually, like, well, how do you formulate what a program is? The easiest way to formulate something like that is to make it really, really simple. And so it's very simple. It's just a text. They do wonderful text adventures in these things. Very creative, some of them too. They're actually pretty cool. And then third one is when data-driven comes in. And so I'd said before, data-driven is one of my concepts for data-oriented design. The reason for this is that it turns out, and I ran into this first year I taught this, students don't actually know what the data in their program is. Kind of weird, but if you talk about data-driven design, you make them pull all the data out of their program as content, which in a text adventure is pretty much the text and the commands for it and the things like that. You make them pull it all out, read it in a file, which they can practice file I/O. Yes. Then you've got greater flexibility in the design. They can make their stories longer. They can use more commands. I've had people do battle systems and things like that when they go a little bit overboard. And all of a sudden, they understand what data is. That data can be commands, data is content. And that's actually a big step forward because previously, when I tried to do this without data-driven design, they were really confused. So they now know what data is. And then I introduce data-oriented design formally and I say, hey, look, there's this thing called data. You're using it. And it's actually a design paradigm. It's a design paradigm like object-oriented is a design paradigm. And first of all, we consider the whole barrage of what's involved in making software, including the hardware, the compiler, what your compiler is doing, and, the actual creation of the software itself. We consider the whole chain. And then we view all software as its input, data transformations, and output. And because I made them do a text adventure where they literally type commands in and it makes a decision and transforms the data and outputs text, they can see that relationship really easily. It's great. And so I go over that then. We go over profiling, make sure we do it throughout the semester. I'm just going over the homework assignments and not so much the lectures, because it gives the order of the course. And here's a really funny thing about teaching intro students that is not the same when I teach my more advanced students. They don't ask the question about why we're not doing object-oriented design. It just never occurs to them. They don't see this. They're just like, oh, this is a different way to solve problems with computers. Cool. And, then they like profiling things. They really enjoy profiling things and saying, my code runs better now. My code has less lines. They like metrics, which is kind of interesting. But they apparently have not yet drunk, the Kool-Aid that says that there is one paradigm and you must solve everything with one paradigm. They have not yet drunk that Kool-Aid. And so it's really great because they learn two paradigms and they, are able to see reasons to use both of them, and that's kind of cool. And we also discuss things like structures of arrays of structures around that time, to kind of iterate on, some of the nice things for data-oriented design. We do a lot of data structures in this class. We do trees and graphs, and a lot of it's fairly traditional, although taught in a games context. The students do come in, they pretty much already know linked list, stacked, and queue. And we do a bit of a review on linked list. We do some profiling. We talk about, cache missing in linked list and how data has to be a certain size until, it actually performs decently. We discuss how memory is laid out. And so, we introduce subjects, but then we try to iterate on them over the course. And, so it's kind of a spiral learning pattern. And then after we know about data, we, can split it up into arrays, basically. I want to do some threading. I want to do some parallelism because, this is kind of the place in the curriculum where they're introduced to just the basic sort of threading things. And it turns out Unity is really helpful for scaffolding this data parallelism, because Unity makes it really easy with a job system to just throw things into the system and get some parallelism for free, kind of. They still have to pay attention to their data. They still have to pay attention that they don't get race conditions with their data. But, some of the things like you can pass your data into the Unity jobs and say, oh, well, it's read-only. And for the students to actually be thinking about this at this point is great. Of course, we have to introduce Unity first. So that takes a week out of things too. Before we introduce Unity, we've got to introduce, things like struct as a value type. Ref and out are used a lot when you're using structures because you don't want to copy the data every time you do things. And so we have to go over that in C#. It makes it easy to talk about reference and value types, which they'll see later when they do the C++ class. Intro to threading, parallel for, we do lambda expressions. We do all of that before we get into Unity's way of doing things. So in a non-transfer course, I might actually introduce parallel for first, because parallel for, you say, oh, we're just doing multiple for loops, like in the image example where we had 2 for loops. So, what happens if we parallelize one of these? Because, changing each pixel and making it grayscale is independent of every other pixel, so we could just do this. And so I might actually introduce Parallel first, but in a transfer bridge course, there's always somebody in the class that knows about threading. And if there is one single person that knows something about threading, they will start asking questions about it, and everybody else in the class is going to go, oh, what is that? And so now I introduced threading first. That was a change between the first time I taught it and the second time I taught it. I was like, I am teaching threading first. And then I teach the Parallel 4 stuff after that, which is what they're going to use when they do their Unity assignment. I introduced the entity component system. It's an easy way to do data-oriented development. However, Unity's entity component system tends to be the most confusing part about the whole thing for using the Unity. Primarily, they have problems figuring out how to get data into it and data out of it, because it still has some hybrid features. And they'll be like, well, I want to use this physics, but I can't use this physics, and then this is not displaying. And so in the past, there has been some confusion over that. So there's a lot of support that I end up having to give students. They're really like, oh, this is how you pass this in. And oh, no, this should not be read-only because you are changing it. So I have to give a fair amount of support with that, because that's most of their problem when using it. Also, they find the worst videos ever from YouTube. They don't look at the unit. I tell them, like, it's okay to look at the Unity videos because they're from Unity. I figure they're good. However, those are not the prime streamers that come up first in searches sometimes. And so they'll find these other people that I have no idea what they're doing, but it's not right. So it tends to be a bit problematic, because there are people out there that are somehow managing not to do data-oriented development with ECS. I don't know how, but they manage. And so you have to watch them. You have to, give them a lot of resources, as many resources as you can, so that they don't go out and find these other resources that may or may not be right. And they have this 4-week-long project at the end. It is a solo project. I thought about making it a group project at first, but I wanted them to be able to demonstrate their mastery of the materials. And so I had them use ECS. They have to use the parallel features of ECS, and you tend to get games that look kind of like this in one way or another. This particular game, that pink ball there, is the character. It's running forward. There are coins that go back and forth across the screen. What you see on the left side is the code for the job to do the coin movement left and right on the screen. And all of those coins, obviously they're all independent of each other. And so they can all be made parallel in the job system if it does that. So that's what it does. And then there are walls that are placed that the player will bounce off of, so they actually have to navigate around the walls. That's that particular final project. The projects tend to be this level of difficulty. Since it's a programming class, I don't give extra credit for having pretty graphics. And so you end up with fairly simple shapes. I've had people do things like asteroids or space invaders and simple platformers. Those are the kind of games I get, with just that little 4-week window. But the cool thing is that they can easily use the job system, and they can come up with meaningful ways to do that. And I've really appreciated that, because that did not exist. It used to be we introduced threading, we had it for a week and a half, and then it disappeared, and nobody ever used it again. And this way they can kind of see that it can be used more often. All of this that I've just gone through takes about 4 weeks out of my semester. Note that I'm combining it with other things. For instance, when I do data-driven, I do file I/O. And so there's a lot of other, like I combine the topics sometimes. So if you do not have 4 weeks to spend in a class on data-oriented design, this is my personal list of what I consider to be the most important and the most impactful things that you can actually talk about that take the least amount of time. Cache and profiling was really it took very little time. It took a day out of my schedule. It had a homework assignment associated with it. And, then I just mentioned it again and again and again in the class. And it took the least amount of time in about everything, but it had the biggest impact because students actually think about their code, think about what they're doing, and you get all sorts of interesting questions about things like garbage collection after this because they're looking at the profile going, what is this big spike here? And you're like, oh, you used a C# memory call here, and it's recreating and then trashing that memory every frame. So you get things like that they start to talk about. That's really been the most impact for me. Other things, the data-oriented design took about a week to actually go through. They have only just begun breaking down problems in terms of data and transformations. Scaffolding after the data-driven design really, really helps because then they know what the data is, and it can be done with an intro to ECS with Unity as well. And then probably the least, I think, well, the least impactful for the amount of time it took, however, one of the most important things that they have to go over in some kind of computing curriculum would be the concepts for parallelism, data parallelism, and using the job system in Unity. And that took about 2.5 weeks because, you have to introduce threading, you have to introduce all these other things, and that takes the most amount of time. However, it has been really nice to see that because they can continue to use that after they get out of the class. Now, as I talked about in my other video, because I did a video on a more advanced course I did, the only drawback to this is that they will go on in class, and sometimes they're afraid to use these features of Unity because there are other students in their group that don't know about these features. And so in the future, I plan to talk more about how to iterate and do things, with other students that may not understand data-oriented design. So that's something that I would like to do. Also, in terms of future work, I have, I've been talking about, I actually went to a talk at my university. Actually, it was an online talk. Everything's online right now, about supply chain management. And so supply chain is basically the concept of, well, somebody grows your food, it goes into a truck, it goes to warehousing, or it goes across the country, and eventually it gets to your supermarket. And that's a supply chain. There's steps along the way. And so this actually is a very rich analogy that I think can be used in order to explain data-oriented design, because of course everything with data orientation is you input the data, you transform it, you output it, and so that's a supply chain. And supply chains in the real world, they have things like warehouses, which, cash. And so I'd like to work more on coming up with a better description about this, on how it is a supply chain, because it seems to make sense to me that it is. And so I plan to do that in the future. Okay, thank you. And if you have any questions, feel free to contact me.